Hello, greetings to you, my dear students. Today we are going to see one very interesting topic, my dear students. Yes, it's graphical transformation, 6th lecture, my dear students. Already we have seen 5 lectures in this topic. Already how many lectures, my dear students? 5 lectures. If you haven't watched the video, please go and check those videos, my dear students. You will find it very useful and as well as very much interesting. Okay. So, the graphical transformation, this part lecture, what we are going to see, let's see, my dear students. So, already we have seen in 5 lectures, my dear students, we have covered polynomial function, rational functions, and now we are going to see what is irrational functions, my dear students. In polynomial functions, I have done 3 lectures, my dear students, and for rationals, I have done 2 videos. And now for irrational also it will take 2 videos, my dear students. Next, let's see what is piecewise function. After that, let's see transcendental functions, my dear students. Everything let's do it and let's do a mass, my dear students. Okay. Okay, now let's see what is irrational function, my dear students. Generally, what is function, my dear students? Function means there is an input and there is the output. In between there is the processing. That processing defines what the output have to be. So I am going to give whatever the input I can, but my output have to be irrational. So that how my function have to be. That thing only we are going to discuss now, my dear students. Let's discuss. So this is the definition for the irrational functions, my dear students. The algebraic function containing the terms having non-integral rational powers of x. This non-integral rational powers of x. This thing matters a lot, my dear students, because of this power only it becomes the irrational function. What is that irrational function, sir? Which means this is the polynomial function, my dear students. I hope you all know. In second lecture, in second video, I explained in detail about x square function. If you haven't watched, please go and watch, my dear students. Okay. So x square function is the polynomial function. Now I have to convert this function into an irrational function, my dear students. How I can convert? Let's see. That's what they have given, non-integral rational power, my dear students. So x power 1 by 2. Okay, if my power is non-integral, that is not a integer value, my dear students. I hope you know. Integer means 0, 1, 2, 3, minus 1, minus 2. Those numbers are called as integers. This is a non-integral rational power, that we can call it as rational, because 1 by 2 means 0.5. If I have that rational power, then it becomes the irrational function, my dear students. Yes, really. So now this function is an irrational function. Now let's draw the graph, my dear students. Today we are going to see x power 1 by 2 only. Come on, my dear students. So the irrational function, now we are going to draw the graph of f of x is equals to x power 1 by 2. Before drawing the graph, my dear students, I always used to ask you, what is the domain? Domain and the range, very important, my dear students. Even for drawing the graph, domain matters a lot, because without domain, it's very hard for us to draw the graph, my dear students, because it matters a lot. 1, 2, 3, 4. So here minus 1, minus 2. First, my dear students, you have to understand what is x power 1 by 2, my dear students. X power 1 by 2 means what? So, square root of x, my dear students. Am I right? They both are same, right, my dear students? Square root of x, which is going to be equals to x power 1 by 2. I hope you understood. Till this part, you have understood, right, my dear students? X power 1 by 2 is defined as square root of x. That means this function is the root function, my dear students. Whatever value I am going to give, it is going to give me the square root of that value. If I give 4, it will give me 2. But here, my dear students, you have to understand one thing. Here, whatever the positive value I can give, even I can give 0, for that 0 I will get 0. But for negative, what value I will get, my dear students? In case For square root of 4, I'll get 2. For square root of minus 4, what I'll get, my dear students? You have to tell me. Okay, so square root of minus 4 is undefined in real value. In real numbers, square root of minus 4, this is undefined, my dear students. These things are defined where, my dear students? In complex numbers. In complex analysis, we will study what is this value, but in real analysis, these are undefined. So, I can't take any of the negative values as my input. Okay. So, in my input, I can't take these values, my dear students. Okay. Or it is going to be here only. These positive values only, no negative side, which means only in first quadrant I am going to, my graph is going to be, my dear students. Will I get negative as output, my dear students? As I said before, root function is the positive function. It never gives the negative values, my dear students. Here you might have the doubt, square root of 4 means minus 2 also is there, right sir? Yeah, it's the doubt. But here when it comes to graph, it's basically the positive function. Root function means itself, it's the positive function, my dear students. It take only the positive values as the output, because here minus 2 is undefined. All the negative part is going to be undefined, and that breaks the basic rule. You always have to check the basic rule, my dear students. If the basic rule is undefined, so it is totally undefined. In the same way, even I can't get the value as minus 2, because minus 2 is undefined values. Okay. So here for 0, I'll get 0, my dear students. Then for 1, my dear students, I'll get 1. Then for 2, it's like 1.414. Likewise, it is growing, my dear students. It is the increasing function only. It is not the decreasing function, but the increasing, that growth is very, 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 very slow, my dear students. That's the saddest thing. So for 4, it reaches here at 2, my dear students. So it grows like this, my dear students, very slow, very, very slow, death slow. Like that it goes, my dear students, because if my value is 100, on the time the output value is just 10. Square root of 100, what, my dear students? Just 10. So only I am saying the square root function is a strictly increasing function, but not the, strictly increasing function, my dear students, but it's growing very slowly, that's all. Now let's go, my dear students. Now let's do research. Let's find all these things, my dear students. What is domain, what is range, symmetric, even, odd, everything let's find, my dear students. So this is the graph they have drawn, my dear students. As I have shown, it exponentially, not exponentially, it grows increasing. The function is completely increasing, and they have also have drawn the y is equals to x. In next slide, let me explain you why y is equals to x is needed. There is one important note, my dear students. I will explain you at the end of the video. Okay, but in this video I'll explain you, don't worry, why this y is equals to x is here. Now let's find, my dear students, our hero x power 1 by 2. What is the domain? As I said before, it takes only the positive real numbers, my dear students, but 0 is also included. So my domain value is r plus union 0 or 0 to infinite, my dear students. Okay, r plus union 0 or 0 to infinite, these both are same only. This only we call it as domain, my dear students. Then what is the range, sir? See the graph. The graph is growing in the same pattern, in the same portion, in the same space. Then what is the same thing as the range, my dear students? R plus union 0. Same thing, my dear students, that is also the range. Domain and range, they both are same in for this function. Now symmetric. Is it symmetric, my dear students? I have graph only in one quadrant. If the x square graph means it looks like this, so it is symmetric about y axis, I can say, because it's sharing the graph in two quadrants. But it's sharing the it is not at all sharing. Don't care about sharing. So how I can do symmetric? So there is no symmetric, my dear students. So this part, symmetric, knowing about symmetric and even odd function matters a lot, my dear students. If your graph don't share any kind of symmetric, then your graph also don't have even function as well as odd function, my dear students. This is very important note. Please make it sure. Please make it down, because these things trouble student. If you know very well, then while solving problem you won't get any kind of problem, my dear students. If the graph is not symmetric, then the function is neither even nor odd function, my dear students. You can check it. Let me check. So my dear students, for even function, what is the condition, my dear students? F of minus x, f of minus x, which is equals to f of x, my dear students. If I get the value like this, then my function is an even function. But here, what I'll get, my dear students? Y is equals to minus root x. So minus root x is undefined, so it is not an even function. Are you all clear? It is not an even function. Then you might think, my dear students, then what about odd functions? It might be odd function, right? Let's check that also, my dear students. For odd function, f of minus x, which is equals to minus f of x. Okay. If the function is f of minus x, which is equals to minus of f of x, then that function is called as odd function. But here, f of minus x is equals to minus, same thing, my dear students, minus root x. But one thing you have to understand, you can't write like this, minus root x. Why, my dear students? Because in real, minus root x itself undefined. That thing itself wrong. You can't do any kind of further proceedings in real numbers with square root of minus x. So they haven't said any kind of rule, my dear students. For that, you can remove the negative outside and you can do the square root. That means everything we can do, right? If it is minus of 100, let me take the minus outside. Then 100 means 10. So minus 10 is the answer. No. So that is also wrong, my dear students. It also don't take the value of odd function. So it is neither odd nor even. Okay, my dear students, I hope you understood it. This symmetric and even odd function concept is very important, my dear students. Now only we have got one good example for non-symmetric function as well as the neither even nor odd function, my dear students. These both have good connections. Okay. Then periodic as I said before, periodic for polynomial functions, rational, irrational, it won't come, my dear students. For trigonometry it will come, for all others it might come, for like piecewise functions like that, my dear students. On the time, let me explain you what is periodic everything. So one-to-one function, this is very important, my dear students. How to find one-to-one function and onto function through graph? In previous lectures I have explained you, my dear students, and I also uploaded one separate video. From that video I have taken that part alone and I have uploaded. If you want to watch directly that video, please go and watch that video also, my dear students. So to find the one-to-one function, what we have to do, my dear students? Just to draw the line. If each line strikes at single point, then that function is called as the one-to-one function. So that function is one-to-one, my dear students. So onto function, what is onto function, my dear students? Through graph, how I can find? So in onto function, you have to be very careful with what? You have to be very careful with codomain, my dear students. If my codomain is R, then this is not an onto function. Why, sir? Why it is not an onto function? Because here the graph is at single quadrant. It is there only in first quadrant, my dear students. It is not there in other quadrants. In R means wherever I draw the line, at least at one time, more than one time is also possible, at least at one time it have to be struck. If it is not striking even at a single space, then for R, that is not an onto function. So you have to be very careful, my dear students. So whenever they have given R as the codomain, you have to check for the entire graph, entire space. So here for the entire space, this is not onto function, because if I draw line here, it is not at all striking. So this is not onto function for R, my dear students, but it is onto function for this. For this, if I have taken this range as the codomain, then my function have the onto function, no problem at all. So onto function by codomain it differs, my dear students. Be very careful with onto functions. Okay. Then bijective function, as I have said before, if they both are one to one and onto function, then only it is called as the bijective function. But here onto may or may not be. So bijective also may or may not be bijective function, my dear students. And increasing or decreasing, it's very important, my dear students. It's an increasing function, as well as it's not simply increasing function, it is strictly increasing function, my dear students. It never comes down, which means strictly, my dear students. They also call it as monotonic. Okay, monotonic or strictly, my dear students. You can use, they use both of the terms, monotonically increasing function, strictly increasing function. They both comes. So from here there is another one property, my dear students. If your function is monotonically increasing, then that function is an one-to-one function. But vice versa is not true, my dear students. Only if the function is monotonically or strictly increasing, then that function is called as the one-to-one. That function is also one-to-one function, my dear students. Vice versa is not true, because one-to-one function, which means also for increasing as well as decreasing function. For example, x square. For x square graph, this function, my dear students, for x square, this is increasing as well as decreasing. Here it is not one-to-one function. For x cube, for x, for that and all, this one is an onto function, sorry, one-to-one function. But on here also they have only one stripe. So you can't say for increasing function also whether it is one-to-one or not. But when it is strictly increasing, you can say it is one-to-one function. But every one-to-one function need not be strictly increasing. Okay. Okay, my dear students. Next, let's see what is derivative. Derivative in this, what is derivative, my dear students. Derivative means it's the calculus topic, which means derivative, differentiation plus continuation. First, let me have to check whether it is continuous graph. If the graph is continuous as well as smooth, then I can say that is differentiable everywhere. If it is discontinuous, it might be differentiable somewhere, my dear students. I have to be very careful. But here you can see this is very smooth as well as continuous for the particular region. So here it is differentiable everywhere, my dear students. I hope you understood it. As well as you can solve this x power 1 by 2, which means n into x power n minus 1. Through using that formula, you can find it, my dear students. Okay. So these things they have explained you, my dear students. Portion of the parabola y equals to x, which lies above x axis. And here see, my dear students, they have only explained the domain f of x belongs to R plus and range alone. They haven't explained anything further, symmetric, even, odd, nothing they have said, my dear students. But I have explained you. I hope you understood. If you have any doubt, please ask me in the comment section, my dear students. Okay. Now let's see why here y is equals to x is there, my dear students. Let me explain you this. So this is a very important thing, my dear students. If f of x and x power 1 by n, which means x square is here and x power 1 by 2. For example, my dear students, I am taking n as the 2. These two graphs are inverse to each other through graph, my dear students. Just a mirror image of x square is x power 1 by 2. That's what they are saying. Let me show you. So the x square graph, my dear students, it goes like this. Then for y is equals to x, my dear students, you always have to draw this y is equals to x graph. Once if you have drawn this, for this y is equals to x axis, the graph is going to be inverse to each other, my dear students. For example, here, which I take this. Already I have said, my dear students, this graph is only possible at first quadrant. So these things I will omit, because these things I no need, my dear students. In my domain I have taken from 0 to infinite only. So what I am going to do, I am going to make that as the y is equals to x, as well as the, oh my god, this is the x square, my dear students. Now for this graph I am going to do the inverse, my dear students. If it is like this, means for this just I am going to do ulta, just the mirror image, my dear students, so that how my graph will looks like, my dear students, it goes like this. This is what they have explained, my dear students, just for your basic understanding. So in some cases they might give x power 100 and x power 1 by 100 means on the time you can find. So x power 1 by 100 means nothing, that is only I have to find the basic of x square and everything is even function. By that you can find everything what I have discussed before, domain, range, symmetric, even, odd function, everything, my dear students. It will make you very simple, which means in exam you, if you spend very less number of time, also you can found the answer, my dear students. Okay, because in exam you have MCQs, so no problem at all. Through graph itself you can accurately say the answer. In calculus, let me explain you in depth to you, my dear students. Okay, okay, my dear students. So this is for f of x, x power 1 by 1 power by 2n. For this thing, what I have explained you before, everything comes true, my dear students. That's what they have explained, my dear students. Whatever I have explained, domain, range, everything. Here also see, my dear students, they said domain and range are going to be 0 to infinite. Just somewhat the graph is for, here it goes, here it goes, like this it change, my dear students. Other than this function is same, this function is going to be equal for the generalized term, whatever I explained you before. Okay, my dear students, I hope you liked this video. If you have any kind of doubts or suggestion, please comment it down, my dear students, so that only I can improve myself, because you are the watchers, you are the benefiters. Then only I can understand, I can give the product in your expectation. So only I am asking you these things, my dear students. And thanks for watching this video. Bye bye. Thank you, my dear students.